Hello, good morning.
Yeah, hi. Good morning.
Hello.
Yeah, tell me.
Morning.
Yeah, tell me, Venkat.
Hi, can you hear me?
Yeah. I am getting you.
Okay, thank you.
Yeah, good morning all. Thanks for joining demo class on AWS DevOps. For a couple of minutes, can you brief about yourself before starting our actual demo? Yeah, one by one. Anil.
Morning, everyone. Yeah, this is Anil. Currently, I'm working as a technical resource. Just someone to switch to
Okay.
DevOps. So
Okay.
yeah.
Okay. Thank you.
Go to the course.
Yeah, Noman.
Hi, this is Abdullah Noman. Now I'm working in supply chain. I want to move in DevOps.
Okay. Okay. Thank you. Logeshwar.
Hi, this is Lokesh. Currently, I'm supporting for BPM admin and VAS admin. So just looking for the DevOps technology.
Okay.
So yeah, that's right.
Okay, thank you. Thank you. Venkat.
Hi, Sheikh. This is Venkat here, Venkat Megasham here. I'm pretty good. I'm having pretty good experience in legacy systems, based predominantly. I'm in management cadre. Currently,
Okay.
I'm leading of 70 plus DevOps engineer in my team. But I don't know anything on DevOps. I don't know anything on DevOps. I want to learn actually. So
Okay.
that's the reason. That's my intention to learn actually.
Okay.
I'm in management side.
Okay. Thank you. So Ashish.
Hi, this is Ashish Khare. I work with PTC Software. I have around 22 and 23 years of experience, mostly on the desktop-based products. And I want to learn something on cloud. I mean, my resume is quite rich on the desktop side, but nothing on the DevOps or maybe on the cloud side. So this is what I want to learn a little bit on that side.
Okay. Okay. So Nilesh.
Hi guys, so myself Nilesh. I have around 11 years of experience, but it's completely into FileNet and middleware. I have some idea on AWS and DevOps, but want to learn more. Yeah.
Okay. Which technologies you are familiar into? Which tools you are familiar in DevOps?
Terraform, Jenkins, little bit of
Okay.
Ansible.
Okay.
Yeah.
Okay. Ahmed.
Yes, my name is Ahmad, and I recently graduated with a computer science degree, and I'm more into business side of the IT, and then a little bit on the coding side. I know a little bit of Python and then Java a little bit. I'm trying to gain experience in DevOps. I have zero knowledge in DevOps right now, and then trying to gain knowledge in Jenkins, like like DevOps services, so I can enhance my future in DevOps.
Okay. 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 Thank you. Thanks all for joining the class. So
Maybe, sorry to interrupt you.
Yeah.
Maybe before you start, will it be possible for you to say or summarize at the end of the course what will we learn or what is the objective? I mean, if high level you can summarize.
Yeah, we are going to start with that only. Okay, what is the content we are going to cover?
Okay.
Okay. So my name is Sheikh Ayas, DevOps AWS trainer. This total course will take around 3+ months. Okay. So it will be around 80 plus hours. In 80 plus hours, I am going to complete the total course. So today's agenda, if you see, just we are going to see the course contents, what are the topics we are going to cover, what are the tools we are going to cover, and the remaining is just basic stuff. What is SDLC? If anyone is joining from out of IT company, for them only we included SD. What is SDLC?
Sir, your
What
voice is
cloud
bit low. Please increase and well.
Yeah, 1 minute. So this is the same for all. Are you getting my voice, or is there any disturbance?
No, it's perfectly all right, at least for my.
It is good.
Yeah, it's good.
Okay, if anyone are facing any voice issues, please rejoin. Okay, so this is today's agenda. We are going to see what are the contents we are going to cover and some basic stuff in SDLC. and basic what is a cloud computing and support from us. So what we are doing is, actually we are going to have classes from Monday to Friday in the morning 7 to 8. The time is fixed one. And on weekends we are going to have interactions. Interactions means whatever we covered in that particular week, we are going to have some screen share sessions from the students, and if we have any doubts, we are going to clarify the doubts, and interview questions in that particular interview point of view, if we are what we have to prepare in the topics covered in that particular week. All these things we are going to cover in weekend interactions. Okay, so these weekend interactions will be on Saturday, so the timing will be different, not the same time. Okay, so class timing will be in the morning 7 to 8, but interactions timing will be in the evening. Okay, then we are going to cover interview questions at the end of every tool, and will help in resume preparations. At the end, after the completion of the course, we are going to conduct mock interviews. Okay, so from real-time experts, you are going to face around 2-3 mock interviews to check your readiness for the interviews. Okay, so let's start with the course contents. Uh, So we are going to start with Linux basics. So mostly we are going to work on Linux platforms. So we'll start with the Linux basics, and in the Linux basics, it will cover around 8 to 10 classes. Okay, in 10 classes, we will cover the required basics from the Linux. So basics means about the Linux file system, and about the Linux permissions, how to stop services, how to kill the process, package installations. So these are some topics. Okay, so we are going to cover that all the concepts are required from the Linux for a DevOps engineer. Okay, so it will take around 10 classes, and it will vary from 10 to 11 like that. And if we completed Linux, then we'll start the actual our DevOps tools like Git. Okay, so version control system. We will discuss about the Git. So in the Git also, we'll start from the basic, and we'll cover the advanced topics like creating branches, merging branches, resolving merge conflicts. Okay, all these things we'll cover. Okay, and this for Git also, it will take around 8 to 10 classes. So here also we are taking 8 to 10 classes. It depends. Okay. So once we cover Git, then we are going to jump into the continuous integration tool, that is Jenkins. We are having different types of continuous integration tools. So Jenkins is one of the popular one. So here, so we are going to take 10 to 12 classes for Jenkins also. Okay, so 10 to 12 classes I will cover Jenkins. So in the Jenkins, from the installation, from the starting of the installation, how we can install Jenkins to the advanced topics like master slave configurations, and different types of pipelines like a declarative pipeline, a scripted pipeline. How can we write, and how can we automate our pipelines? So all these things we are going to cover in the Jenkins. Okay, so by using different plugins, and how can we integrate Maven. Maven is the build automation tool. We are going to cover about Maven also. Okay, so in 1 or 2 classes I will discuss about Maven also. So how can we integrate Maven, and how we can build the actual code. All these things will cover under Jenkins. So it will take around 10 to 12 classes. So then we are going to start with the containerization tools like Docker. So in the Docker, we'll start from the installation. How can we install Docker? And we'll start from the basics of the Docker, how can we write a Docker file? How can we create Docker images? And how can we create a containers? So all these things I will cover. And in the Docker, we are going to cover advanced topics like Docker networks, Docker volumes, Docker swarm, and Docker compose. So all these things we are going to cover. So this is about Docker. So the Docker we will take around here also we'll take around 17 to 20 classes. Okay, so up to 20 classes I will take for Docker, and then after the completion of Docker, we will start with container orchestration tool, Kubernetes. So in the Kubernetes also, we are going to see how can we create a Kubernetes cluster, and how can we create pods, and what are different types of objects, how can we create a deployment, and all these things. So we are going to discuss, and we are going to discuss about Docker volumes, like persistence volumes, persistence volume clients, namespaces, and Docker networks, and health probes, and config maps, horizontal part auto scaling, ring disk controller. So like that, most of the advanced topics we are going to cover in the Kubernetes. So it will take around 12 to 15 classes for Kubernetes. Okay. So once we complete Kubernetes, we'll start with the configuration management tool, that is Ansible. We will cover. For Ansible, we'll take around 5 to 7 classes. Okay, and so it will take up to 5 to 7 classes, and once Ansible completed, we are not going to start Terraform. We will start with cloud computing. Okay, we are going to cover Amazon Web Services. So in the Amazon Web Services, we are going to discuss different tools like EC2, auto scaling, load balancer, AMIs, and S3. IAM, RDS, CDN. These topics we are going to cover from the Amazon Web Services. So it will take around, for AWS, it will be around 12 to 15 hours will take. Okay, so 12 to 15 classes we are going to cover AWS. Once AWS is completed, we'll start with Terraform. Okay, because there is a dependency between cloud computing and Terraform. That's why after the AWS is completed, we are going to start with Terraform. So for Terraform also, we will take around 5 to 7 classes. Okay. So this is the agenda. So totally you are going to get around 80 plus classes to complete the total course. Okay. So these are the contents we are going to cover. So if you have any doubts with the contents point of view, we can ask now.
So just a quick question. Sorry.
Yes.
So just a quick question. I mean, mostly we are on Windows. So when you say you start on Linux, so do we need to do any some setup or something? Because
yeah, so all these things we are going to discuss. For Linux, we are not going to install any softwares in our local machines. What we are doing is we are going to get virtual servers from Amazon Web Services. Okay, so from Amazon Web Services, we'll get virtual service. These servers are free of cost. We no need to pay anything for these servers. So if you don't know about AWS servers, so this is the website. From this particular website, we are going to create our virtual servers. So what we have to do is we have to create an account in aws.com. Okay, amazon.com, aws.amazon.com, and I already have account here. So once we create account, we can create any type of virtual servers, whether it is Windows or Linux or Mac, any type of virtual servers we can create. Okay. So
And
let's see.
just a quick question. And then is this the syllabus is good for like beginner, like with zero knowledge?
Yeah. So that's why I told at every topic we are going to start from the basic, whether it is a Linux or whether it is a Git or whether it is Jenkins or Docker, whatever the topic we are going to discuss. We are going to start from the basics only, because nowadays non-IT people are also trying to move to IT into DevOps. Okay, so by considering them, we planned the course from the basic. Okay, from the basic topics to advanced topics. Even the guys are from non-IT, they can easily follow the course.
Okay.
Yeah, so this is the website. From this particular website, what we have to do is we have to get the instances. So if you see here, I already have two instances. One is a Linux instance, one is a Docker instance. So we can launch these instances, and we can directly connect it to these virtual instances, and we can do the practice on these Linux instances. Okay, so no need to install any software in our local machines.
Okay.
Yeah, so any more doubts?
No.
Yes, okay. So that's about the course contents, okay. And so most of you are from IT domain only, so you already know what is a SDLC, okay. In the SDLC, what we are doing is, so SDLC is nothing but end-to-end process from start of our project to. So what are the phases we are going to have under SDLC? Just be an interaction session, because most of you are from IT domain. Okay. So what are the phases we are going to get in SDLC? So SDLC is nothing but software development life cycle. Okay. So in any SDLC process, we are going to have different phases. Like first of all, if you want to start any project, okay. So we all already know what is a project. Okay, what is a project means. So here a project is nothing but development of an application. Okay, so to start our project, okay, we need planning on our SDLC. Okay, project is nothing but development of any application like IRCTC, Amazon.com, Flipkart, like that applications. Okay, so we are going to work on these projects. Okay, so before the start of any project, we need planning. Okay, so planning will be the first phase in the SDLC process. So in the planning, architects comes into action. They will provide plan for our project, whatever the project we are trying to build. For this project, architects will come into action. They will provide their plan. Okay. So once planning is completed, what is the next phase? Be an interactive, please. So once we got the plan, so we have to develop the code depending on the plan. Okay, development of the code. Okay, code development. So now in the code development, development people come into action. They will develop the code. Okay, so once we have the code, what is the next phase in our SDLC, in our software development life cycle? The next phase is we have to test the code. Okay, this is the next phase. So we are having. So once our test cases are success, our code is our code. If our code don't have any bugs, what is the next phase? We are going to deploy the code. Okay. So these are the common phases. So these are the common phases. So we are having in every software development life cycle. Okay. So to start any project, before the start of any project, we need planning. Once planning is completed, we have to develop the code. On development of the code completed, we have to test the code, and we have to perform the deployment action. Okay, so these are the different phases we are having in every software development life cycle to start any project. Okay, so we already know we are having some traditional way of SDLC. What is the traditional way of SDLC? What is that? Can you come again?
The waterfall deployment.
Yes, we already know waterfall model is there. Okay, waterfall model. In the waterfall model, what we are doing? In the waterfall model also, we are going to follow all these stages. Okay, so here also we are going to plan our project. We have to develop the code for our project. Okay, and we have to test the project. Okay, and we have to deploy the project. All these phases we are following in the waterfall model also. Okay, so in the waterfall model, what we are doing is, so once the planning of our project is completed, we are going to develop the code for the total project. Okay, for the total project, whatever the plan we have, depending on the plan, we are going to develop the code for our total project. Okay, so we are going to get a single executable file here. Single executable file we are getting under waterfall model. Okay, and here we already know to develop the code, it is not going to happen within 1 or 2 days. It will take some time. Okay, so as we are developing the code for our total plan, let us consider we have taken around 1 year to develop the code for the functionality for which we are having in the plan. Okay, so after 1 year, our code will be ready, and our code will go to testing phase, and our code will go to, if the testing is a success, okay, if all test cases are success, then we are going to deploy our code. Okay, so means whatever the plan we have for this plan, after 1 year, our code will go into live. This is the waterfall model we are following. Okay, here the drawback is we have some plan. Okay, so for this plan, our total code will goes to live after 1 year. Okay, so after 1 year, there is a chance that there is a possibility that our requirements are going to change. Our plan is going to change. Okay, there is a possibility that our plan is going to change. So after 1 year, when our code is ready to move to production, at that time, if the plan changes, then what we have to do? Again, we have to work from the base, from the beginning. Okay, we have to change all our code. There will be the dependency, because we are having single executable file. Okay, so like that we are having different drawbacks with the waterfall model. Okay, so due to this, we are implementing agile methodology. Okay, nowadays we are implementing agile methodology. So in the agile methodology, what we are doing? What we are doing in the agile methodology? In the agile methodology also, for every project, we are going to have same phases. Okay, whatever the phases we discussed here. So we are going to have a plan. We are going to develop the code. We have to test the code. We have to deploy the code. Same phases are there in agile methodology also. Okay, so nowadays most of the organizations are using agile methodology in their SDLC. Okay, so in agile methodology also we are having planning, development of the code, testing of the code, deployment of the code. Okay, so the difference between waterfall model and agile methodology is, in the agile methodology, once we got the plan for our project, what we are doing is we are going to divide our plan into number of features. Okay, we are going to divide our plan into number of features, and the development of the code happens on sprint basis. We already know what is a sprint. Okay, so for these features, the development of the code is going to happen on sprint basis. Okay, so means on every sprint we are going to have some requirement. Our developers are going to work on that particular requirement only. So mostly sprint means around 2 weeks or 10 days. Okay, in most of the cases. Okay, so 2 weeks. For these 2 weeks, we are going to have some requirement for our feature. On that requirement only our development team is going to work. Okay, and we are not going to have a single executable file as we are having different development teams for different features. Okay, and different development teams are going to work on different features on sprint basis. Okay, so if there is a change in the plan, if there is a change in the requirement, so that change we are going to implement in the next sprint. No need to wait for 1 year like waterfall model. Okay, so that is the advantage with the agile methodology. Okay, so in the agile methodology, the speed of production increases. If you observe the difference between waterfall model and agile methodology, in the waterfall model, our project will come to live after 1 year, but in the case of agile methodology, within short duration, our code will come to live. Okay, so here the speed of production increases in the agile methodology. Okay, so once the development of a code is completed, we are going for a testing phase and we are going for a deployment phase. Okay, so when all test cases are success, then our code will be into live. Okay, we are going to move our code into production. Okay, so like that we are having many advantages with agile methodology compared to waterfall model. Okay, so with the agile methodology, what we are doing is we are increasing the speed of production, we are increasing the quality of production. Okay, so here in the agile methodology, to increase this speed of production, we are going to use the DevOps tools like Git, Jenkins, Docker, Kubernetes. These are the tools we are using to increase the speed of production in the agile methodology. Okay. Okay. So in our course, we will see how can we use all these tools. So we are going to cover about a source code management tool. Okay, source code management tool with one of the popular SCM tool, Git. We will start with Git. Actually, DevOps course, so we'll start with Git. Okay. So what is the purpose of Git here? So we already discussed our developers are going to work on sprint basis. Okay, so on every sprint, our developers will release some version. On sprint 1, if we have version 1, on sprint 2, we will have version 2, on sprint 3, we will have version 3, like that. Okay, so to maintain all these versions, we need version control system. Okay, so version control system are SCM, source code management tool. Okay, so we are going to discuss about Git, one of the popular version control system. So here we will see how can we install Git and how can we work on the Git. Okay, so how can we maintain different versions? If you want to revert to previous versions, how can we revert? Okay, so that is the purpose we are going to learn SCM tool. Okay, the purpose of learning this Git is to maintain the different versions. How can we maintain the different versions we are getting from the development team? Okay, so this is one of the role of a DevOps engineer. We are going to maintain the repositories. Okay, and in repositories we are going to maintain the code from different developers. Okay, and here we are going to if we got any merge conflicts, we are going to involve, okay, to resolve the merge conflicts also. So once our code is ready, okay, our code is ready, then what is the next phase? So once our code is ready, So the next phase will be, we have to work onto the code. Okay, we have to work onto the code. So to work onto the code, we are introducing continuous integration tool. Okay, so what this continuous integration tool will do is, so it will pull the code. It will pull the code from source code management tool. Okay, SCM tool like Git, and it will perform the different operations depending on our requirement. Okay, so we have to perform the code quality analysis. We have to perform the test cases. We have to compile the code. We have to perform the build operation. All these operations we are going to perform with the help of continuous integration tool. Okay, these operations we can do manually also, but we are using some continuous integration tool to automate all these processes. Okay, to automate all these processes. What are the processes we are going to automate? We are going to automate to pull the code. We are not manually doing. Okay, to pull the code from SCM tool, we are not manually doing. Continuous integration tool will do. Okay, to perform the code analysis, we are not manually doing. We are going to use a continuous integration tool. We are going to create a pipelines here. Okay, in the continuous integration tool, we are going to create a pipelines to perform all the operations. Okay, so we are going to see how can we create a pipelines by using continuous integration tool to perform all these operations. So okay, that is code analysis and getting the artifacts from the continuous integration tool. Okay, storing these artifacts into repositories. So all these things we are going to cover under Jenkins, continuous integration tool, Jenkins. Okay, so once we have artifacts here, what we are getting from the continuous integration tool, what we are getting from continuous integration tool, now we are going to get artifacts. Okay, artifacts we are going to get from continuous integration tools. So artifacts like a jar, here, where files we are going to get. Okay, so once we got artifacts, so these artifacts again depends on the version. Okay, for we already know we are having a sprint model. We are following sprint model. So for every sprint, we are going to get different versions of artifacts. So to maintain all these artifacts, we are going to store these artifacts into artifactory tools like JFrog. Okay, JFrog or Nexus. Okay, so like this artifactory tools we are going to use to maintain the different versions of the artifacts. Okay, so once we got artifacts, and our the next phase is we have to deploy these artifacts. Okay, so to deploy, we are going to use Ansible as a deployment server. Okay, we can use Ansible or Docker, Kubernetes. These servers we can use to deploy our artifacts. Okay, so to deploy artifacts into our deployment servers. Okay, so this is the flow. So if you observe from the development of the code to the deployment of the code, we are using the different tools like Git. We are going to study Git, and the continuous integration tool we are using. So we are going to see how we can work with continuous integration tool. How can we create pipelines with the continuous integration tools? Okay, how can we push our artifacts into artifactories like a JFrog and Nexus? Okay, and once our artifacts are ready, how can we deploy our artifacts into deployment servers? So this is the flow we are going to cover in our total course. Okay, so this is okay. Now we are going to cover Git and Jenkins. We are going to cover Ansible. Okay, then what is the purpose of Docker and Kubernetes? Why we are studying Docker and Kubernetes? So the purpose of Docker and Kubernetes is, so before discussing Docker and Kubernetes, so if we don't have the containerization tools like Docker and Kubernetes, So to deploy our application, so we have our artifacts. Okay, we have our artifacts. Now I want to deploy my artifacts into different environments. Okay, so we already know we are going to have the different environments like dev environment we are going to have, and a testing environment like SIT or EOT. Okay, EOT. Okay, and let us consider we are having only 4 environments, prod environments. Okay, so pre-prod will be there. Okay, so here I am taking only 4 environments in our organization. We have dev environment, SIT environment, UAT, prod. Okay, so pre-prod or UAT, we can consider any one of this. Okay, so now I have artifacts. Okay, I have artifacts from my sprint model. Okay, I am maintaining the different versions of the artifacts in my artifact array. Okay, and I am using these artifacts to deploy into dev deployment servers. Okay, so for my application, let us consider for my application to run seamlessly, I need Java 8. I need Java 8. Okay. So if I have Java 8 in my deployment servers, my application will run seamlessly without any issues. Okay. So I am maintaining Java 8 in development environment deployment servers. So application will be success. Okay. Without any issues, my application will run in development environment. So once my code is um, up to date as per requirement, so what I can do is I can move the same code to the next environment also. Okay, so whether it is a SIT or UAT, so I am moving the same code because I am very much confident that my code is running successfully in a dev environment. The same code I can execute in other environments also without any issues. Okay, but in SIT environment there is a configuration change. Okay, I am using Java 7. Okay, I'm not using Java 8. I am having Java 7. Okay, so I neglected that configuration change. So I thought my code is going to work in SIT also. So in this case, what will happen? My application needs Java 8. Okay, but in SIT I have Java 7. What will happen to my application? It is going to fail. Definitely it will fail. Okay, so if you observe here, there is no change in the code what I deployed in dev environment and SIT environment. Okay, in dev environment my application is successfully deployed, but in SIT it is failed. Why it happened? Because there is a configuration change. Okay, there is a configuration change. I need Java 8 but I don't have Java 8. Okay, so this is the scenario we are having if we don't use containerization tools. Okay, if we don't use containerization tools, so means to rectify like this configuration environment related issues. Okay, we are going for containerization tools. So one of the advantage with the containerization tools is if so this is the case before if we don't have containerization. Okay, with no containers. Okay, before, let us consider before containers. Before containers are okay, or no containerization. Now what I am doing is I am going to implement containerization in my environment. I am using containerization. Okay, I am using containers. Okay, so if I have containers, what I can do is, so already we know we are having artifacts. We are getting artifacts from our continuous integration tool. Okay, so these artifacts I am using. These artifacts I am using to create images. Okay, so with these artifacts, so with the help of artifacts, what are the artifacts I have? with the help of artifacts, I am going to create images in the containerization by using container tools like Docker containerizing. Okay. So what is an image means? An image is nothing but the combination of application code and the libraries, binaries, and required all dependencies. Okay, all dependencies. Okay, all dependencies we are going to get in the image. Okay, so I am going to create image for by using the artifacts from the containerization tools like Docker. Okay, so I'm going to get a Docker images. Okay, I'm going to get Docker images. This Docker image consists of application code and libraries, binaries, all dependencies required for my application to run seamlessly in any environment. Okay, so for my application, if I need Java, okay, Java 8, okay, if I need Java 8, this Java 8 I'm going to use in my image. Okay, I'm going to use Java 8 in my image. Okay, so as I have all the required dependencies, libraries, binaries, and application code, if I use this image in a dev environment, okay, so in a dev environment, I am going to use this image, okay, by image to deploy into dev deployment servers. So as this image is having all the dependencies, there is no chance of failure for my application. Okay, so Java 8 I included in my image itself. Java 8 I included in my image itself. Okay, so my application will run seamlessly. Okay, so my application will run seamlessly. I can deploy my application without any issues in dev environment. Once my application is successfully run in one environment, so no need to bother about the deployment issues in the remaining environments. Okay, whether it is SIT, EAT, or prod environments. Okay, so this is one of the biggest advantage with the containerization tools. Okay, so once our application is successful, if our application runs successfully in one environment, we can mostly we will give guarantee that due to this Java 8, like the dependencies, my application is not going to fail in the remaining environment. Okay, so in SIT, if I am using the same image, it will be success. Okay, it is going to success. Similarly, in UAT, if I use the same image, okay, so it will be success. Okay, so that is the advantage with the containerization tools. Okay, so the same image we can use in any environment. Okay, so that is the purpose we are studying Docker. Okay, Docker, by using Docker. We are going to study how can we use these artifacts to create the image. Okay, so how can we use these artifacts to create the image? So once we have image, we are going to convert this image into containers, and we are going to work on the containers. So that is the purpose of Docker. And similarly, we have containerization orchestration tool like Kubernetes. So the purpose of Kubernetes is nothing but a container orchestration tool. Okay, so this is a container orchestration tool. So if we have some hundreds of containers, okay, if we have some hundreds of containers, to maintain this all the containers, we need some orchestration tool. Okay, we are going to learn about Kubernetes. Okay, so here what we will do is we can learn how can we maintain, how can we scale up our containers, how can we attach volumes to our containers. Okay, so all these informations we are going to study under Kubernetes. Okay, so Kubernetes is nothing but just we are going to maintain the containers, the existing containers. If you have hundreds of containers, Maintenance of these containers is not possible with the help of Docker. So Docker is having one of the containerization tool like Docker Swarm, but compared to Docker Swarm, Kubernetes is having many advantages. Okay, so we'll see how can we create a clusters by using Docker Swarm, and how can we create a clusters by using Kubernetes. All these things so we are going to study. Okay, so this is this is a necessity of containerization tools. Okay, for that reason, so nowadays most of the organizations are moving into containerization platforms. Okay, so that's about Docker and Kubernetes. So once we complete Docker and Kubernetes, we are going to discuss about Amazon Web Services, cloud computing, and Amazon Web Services. We will see different concepts like how can we create virtual servers, and how can we create different types of storages. Okay, virtual storages, and how can we create virtual databases. Okay, all these things we will cover. Okay, after the cloud computing, we are going to work with Terraform. Okay, Terraform is like a infrastructure as a code. So in the cloud computing, what we are studying is, so to create a server, what we are doing, we are going to launch the instance manually. Okay, and if I want to if I want to create any that is S3 storage. Okay, if I want to create a S3 storage, what I am doing is I have to go to S3. Okay, and here I have to manually create a bucket. Yeah, I have to manually create bucket. Means every operation we are doing manually in the Amazon Web Services by using AWS console. Okay, but if we use a Terraform, which is a IAM, the infrastructure as a code tool. Okay, so all these services, instead of creating manually, with the help of code, I can create the servers. Okay, with the help of code, I can create these storages. Okay, with the help of code, I can create volumes. All these things I cannot do with the help of code. Okay, and we can easily scale up the services by using Terraform also with the code. Okay, we will see. We are going to discuss how can we achieve all these things by using the Terraform also. Okay, so this is the brief introduction about our course. So if you have any doubts, you can ask now.
Hi guys. So for this Kubernetes, everything we will do it is on EKS only.
Not on EKS, what we are doing is we are going to create a Kubernetes cluster like on premises. What we are doing is we are going to create instances from AWS, and we are working on this cluster.
Okay,
EKS is
okay.
different. Yeah.
Okay.
And for Terraform, are we learning the language, or are we just implementing it, using it?
Yeah, both we are doing. Okay, we are learning the language and we are also implementing.
Okay.
What would be the session timings generally?
Yeah, timings morning 7 to 8 daily, Monday to Friday. And Saturdays it will be evening. Only interaction will be there on Saturdays. Timing will be between 6 to 8 p.m. IST for Saturdays. The class timings will be 7 a.m. to 8 a.m. IST.
Okay.
And when is the classes starting?
Tomorrow, from tomorrow onwards, we are starting the class.
And also, do we have like, are we in this course, are we doing like projects along the way?
Yeah, so we are going to create around 2 projects end to end.
Okay. And also, after completing the course, like what do we expect? Like what knowledge or what information are we gonna gain?
Yeah,
Like for
so
the
we already informed means so this 3 months of course equal to always almost you are going to get 4 years of experience like knowledge. Okay, because we are going to discuss only real time scenarios only. Okay, not theory classes. Everything will be demonstrated, and we are going to have screen share sessions with you to perform some of the assignments. We will provide some assignments also. So there will be screen that is a demonstration session from you also.
okay.
Is 7 to 8 is fixed, or is there some flexibility there?
Most of the cases it will be between 7 to 9 only, depending on the requirements from the students. Some of them are in working profession, so most of them are asking for 7 to 8 like that, before to close before 8 like that. That's why we fixed it 7 to 8.
Okay.
Is there any plan for placement as well? And just a question.
So placement assistance will provide. We are
Okay.
not giving assurance, 100% assurance like that. Okay. So if you
That's
observe here, we are having weekend interactions where you will have you are going to gain much of the knowledge about the interview questions. Okay, how the interview questions will come, how you have to answer all these things. You are going to involve. It will be very much helpful for you. Okay. So we'll provide a placement assistance.
oh,
Yeah. Anything else?
And yes, also, are we going to learn or are we going to implement like any backend programming language like as a scripting Python or anything?
Shell scripting we are discussing. Shell scripting will be there. Around 3-4 classes, we will have shell scripting at the end of the course. After
Okay.
Terraform, we will have.
Okay. And also, as a DevOps career, does a lot of Python or any other backend programming involves?
No, not necessary. Okay. Scripting is enough as a DevOps guy.
Okay.
If you have any programming knowledge, it will be an added advantage only.
Okay. Okay.
Better to have like that.
Okay.
Another quick question. I mean, I don't know how relevant is that.
Yeah.
We have a lot of legacy applications and programs which are already, monolithic and running fine. And now
Yeah.
there's a lot of traction to move them on cloud. So is this
Yes.
code going to cover that aspect also, or not?
Yeah, so that's why we included cloud computing also. Okay. So what are the tools we need as a on which tools we have to work from cloud perspective as a DevOps engineer? So all these tools we are going to cover under cloud computing.
No, my question was a little different. I mean, suppose I have a program which is running in-house on-prem program, and we want to move it to cloud. So
yeah, so you are asking about migration
migration
from
yeah.
A migration point we are not going to discuss. Okay, so once you study all these topics from cloud computing, you will get some idea how can we implement migration like that also. But we are not going to teach and that is directly how we will do migration like that.
Okay.
Okay, anything else?
No, no questions from.
Okay, thank you. Thanks for joining the class. If you have any doubts, you can ping in the chat also.
Sure. Thank you very much. Nice introduction.
Okay, thank you.
Thank you, guys.
Bye-bye.
Thank you so much.
Bye
Okay,
bye.
thanks
Bye
all for
everybody.
joining the class. Okay, thank you.
Thanks, guys.
Hi guys.
Yeah, hi.
One question. Sorry for late
Yeah.
questioning. Is this classes are uploaded in Google Drive or somewhere?
Yeah, so at the end of every class, we are providing recordings also. In the Google Drive, you will have a lifetime access for all the recordings.
All right. So the time class time will be 7 to 8 a.m. Is it?
Yeah, 7 to 8 a.m. IST. So after the class, within 15 minutes, you will get the recording also.
All right. Thank you very much.
Okay, once again, thank you all. Thanks for joining the
Thanks, sir.
class. Yeah.
Thank you, sir. Bye.
Yeah.